Welcome to Life Cycle Talks, a series of talks presenting the research front to keep you up to date with the science and application of the life cycle perspective. Today's Life Cycle Talk is How Low Should You Go? Towards Standardized Absolute Environmental Sustainability Assessment, where we will learn more about this field, Absolute Environmental Sustainability Assessment. My name is Anna Wikström, and I'm happy to welcome our guest for today, Andrea Paulillo, lecturer in Sustainable Chemical Engineering at University College London, and Anders Bjørn, associate professor in Sustainability Assessment at the Technical University of Denmark. Before we start, I just want to give you some practical information. All Life Cycle Talks will be published and available on the Swedish Life Cycle Center YouTube channel after the live event has ended. And the raise hand function will not be used in Life Cycle Talks. Please feel free to submit your questions using the Q&A function. We will select a few to address during the Q&A session after the presentation. I will start with a warm-up question for you. I'm curious, what motivated you begin exploring this area of research?
Well, maybe I can answer that question. When I studied LCA in my master's nearly 20 years ago, I thought it was a really powerful tool to understand the environmental impacts of systems in a holistic perspective, but I always felt that it missed a link to the big picture, to global challenges. So since then, I have worked with putting LCA results in the context of planetary boundaries and other global goals.
Okay, great. Thank you so much and warm welcome. It's time for your life cycle talk.
Thank you very much, Anna. I'll kick off this talk by explaining what is absolute environmental sustainability assessment, and then I will introduce the first technical guidance on AESA and how basically was developed and its structure, and then we will describe, Anna will be describing the framework in a bit more detail and the different steps, and we will conclude with some future outlook. So let's start with the beginning. AESA, it's really a paradigm shift in the way we assess the environmental impacts of system, products, organizations, or larger systems. So what we typically do in LCA is that we quantify the environmental impact of a product, say product A, and then we compare it against, say, product B or a benchmark. And if the environmental impact of our product is lower than the benchmark, then we are typically satisfied, and some might say that this product is sustainable. Now, the problem is that we know that at global level, we are exceeding the Earth's carrying capacities or the planetary boundaries. So we know that our impacts are way exceeding some global thresholds. So if we compare these systems against a form or a measure of this threshold, we will find that they would both be exceeding this threshold. So the traditional way of assessing environmental impact, we would have found that product A is less bad than product B, but is still environmentally unsustainable. What we need to do, we need to find products or optimize products so that their environmental impact is below this threshold, so that basically they are environmentally sustainable. So absolute environmental sustainability assessment is a novel approach that aims at determining whether an anthropogenic activity is environmentally sustainable by comparing its environmental burdens against a measure of the Earth's carrying capacities or the planetary boundaries, which are an example of that. So Anas and I contributed to the first technical guidance for AESA, and you see a screenshot on the right-hand side. And the reason we developed that is that we realized there is a lot of interest around this methodology. However, there is still a lot of inconsistency in terms of terminology or methodological choices, which we feel might hinder further mainstreaming of this methodology. So the aim of this technical guidance is actually twofold. On the one hand, we wanted to synthesize and harmonize at least our interpretation of the academic literature into a single document. And we also, at the same time, wanted to show how to carry out an AISA in an accessible and practical way by providing a number of examples at different scales. So the target audience for this guidance is wide. Of course, researchers will form the bulk of the readers, but we also targeted practitioners from the professional world, consultants, industry, government, and also civil society. There is only one requirement, is that the readers must have a basic understanding of LCA or similar tools, because of course we didn't want to reinvent the wheel with this guidance. So here is a link, basically a QR code and a link to the guidance, and the guidance is published as a JRC, Joint Research Center technical report, and that's basically the screenshot you can see when you find it online. Now, how was this developed? So the guidance was developed by 7 authors, you can see on the right-hand side, and it was a joint effort from 3 institutions, the Technical Denmark University, University College London, and the Joint Research Center. And the basis for developing this guidance was basically our collective knowledge of the scientific literature and on the existing LCA standards, as well as our experience in doing research, teaching AISA, as well as supervising students. So how did this work? How will this work in the future? So we published a beta version in early 2025. And this is a beta version because we wanted to basically improve it via further internal testing, as well as we put out a call for feedback to the wider community. And actually this call, there is a QR code there, will be open until the 31st of October 2025. Using this feedback and further internal testing and the outcome of this internal testing, we aim to publish a final version in early 2026. So how is the guidance structured? So on the left-hand side, you can see we developed a framework for conducting AISA that basically will guides the practitioners from start to finish. And the framework includes 3 phases, 9 steps, and also 11 sub-steps. And to make it accessible, we developed 3 illustrative case studies going from the product scale buildings in Denmark to a company, a major cement company, to all the way to total consumption in the European Union. And we also provide an example of how to do this via environmentally extended input-output analysis. Now I will leave the word to Anas, who will guide you through the different steps and phases of the framework.
Thank you very much, Andrea. And yeah, here you see the framework in full screen. So it is composed of 5 steps within the environmental estimating environmental burdens, the first phase. Then there are 2 steps belonging to the phase of allocating carrying capacity, and finally 2 steps belonging to the interpretation of results. So next slide. So now for the first step, which is about defining the goal of the assessment. Well, this is very similar to what we do in normal LCA. We clarify the reasons for carrying out a study and its intended audience, because that will guide certain choices later on in the assessment. Next slide, please. Then we describe the activity, meaning what is produced or consumed over a defined period of time. So if you are at the product scale, then this is very similar to simply stating a functional unit, and you should follow conventional LCA for doing that. If you, however, are at the company, industry, or higher scale, then it's about stating the quantities of individual products that are produced and or consumed, as well as noting the number of people who are consuming the products if relevant. Next slide, please. Then you want to plan your environmental accounting. First, you choose an accounting approach, and that will very much depend on the spatial scale of the activity you are studying. So it could be process-based LCA if you're at the product level, or it could be, for example, environmental extended input-output modeling if you are at the regional level. No matter what you choose, it's important to follow an attributional accounting philosophy. And that is because this is how we can ensure that there's additivity in the assessment, so that in theory at least, the environmental burdens quantified for individual activities, they will sum up to global environmental burdens. Ideally, there should be a full life cycle perspective, so cradle to grave, because in that way we avoid burden shifting. Because of the need for attributional accounting, it's also important to deal with multifunctional processes in a way that doesn't compromise attributional accounting. And that means if you do substitution, it should still conform with this additivity requirement. Finally, a note on temporal and spatial variations. So this can go all the way from very highly resolved assessments of individual, for example, watersheds and months, up to something that's more globally aggregated or globally averaged. Next slide, please. Then you quantify the environmental flows related to the impact categories that were chosen in the previous step. So this is about sort of iteratively collecting primary data, collecting secondary data, and then using some sort of software tool to build a system of processes, including these environmental flows that are scaled proportionally to each other. So this is very similar to what we do in life cycle inventory assessment, for example. Finally, you use characterization factors to quantify the resulting environmental burdens, and you should pay special attention to the handling of, again, temporal and geographical variations that was already determined in step 3. Next slide, please. Now we made it to phase 2 of the assessment. So this is in the first step here. It's about developing a list of quantified carrying capacities. And the point is to obtain that from existing literature or data set. So the analyst should not themselves go out and try to estimate these carrying capacities. It's more about obtaining existing data sets. And then it's very important to make sure that there's a match with the impact categories and also the environmental indicators and units that the characterization factors calculating the environmental burdens relate to, because you need to have this comparability. To give some examples, in the bottom left corner, you see one of the case studies on the 40 buildings where the carrying capacities are listed, and they are largely compatible with the EF 3.1 LCIA method. On the other hand, on the right side, you see the other case study of the EU consumption, and there the impact categories actually follow exactly the planetary boundaries impact categories, let's call them that, through this PB-LCIA method. So the impact categories and the indicators and the units are quite different from the picture you see on the left. Next slide, please. Then we made it to maybe the most controversial step of AESA, which is about allocating the carrying capacities that are global or sometimes regional to the activity that you're studying. And so there are 3 steps involved here that are also typically done iteratively. So it's about choosing one or more allocation principles. Then it's about collecting the data that is required, and then it's about applying the equations embedded in the principle. What we see in the bottom left corner is our sort of rough survey of the 8 principles that are used the most in the AESA literature. Starting with grandfathering and ending with cost optimization. And we also rank them by use. So grandfathering and equal per capita are the ones we observe used the most. What you can see on the bottom left, bottom right, sorry, corner, is an overview of the individual principles that apply to translating or to downscaling, you could say, between different levels. So you can see a lot of principles can be applied to go from the global to the country or region level. Whereas going further down from country to product level, we are all of a sudden left with a fewer options of principles. It's important to point out here that our guidance is not prescriptive in terms of what is the right allocation principle to use, because I don't think that's the role of a method developer like us to be prescriptive in this way. We are simply providing an overview and a structured way that you can approach it. It's also very important to mention that you should also always apply at least 2 different allocation principles, a combination of principles, to get an idea of how sensitive your results and conclusions are to this choice of allocation. Next slide, please. Here you see the step 8, which is about comparing environmental burdens of your system with the carrying capacity share that has been allocated to it. This should be done for each environmental indicator separately. And also, if you have a spatial, high spatial resolution or temporal resolution, it should also be done for each region and time step. And here is an example from one of the case studies where each is you see the different impact categories, and then each symbol represent a unique allocation principle. And you can see that all the data points that are to the right of the one line, there the environmental impacts or the environmental burdens are higher than the allocated share. And so you can see that in some cases there's quite a span from the highest allocation to the lowest allocation, which also underlines the importance of not just choosing one principle when you're performing this assessment. Next slide, please. So now we are at the point of interpreting results in the end. And this is somewhat similar to what you would do in a normal LCA. It's really about integrating an uncertainty and sensitivity analysis, I already mentioned that different allocation principles, but there could be other things like what are the environmental indicators used and the carrying capacity values. And then in general, it's about identifying parameter choices that are both uncertain and very influential on results, because that can both, if you have more time, it can lead you to go back and maybe improve the accuracy of some data or make a more informed choice. Or it's something that's important to keep in mind when you communicate the results and conclusions to the decision maker, that everything is referring to certain limitations that are in the study. Yes, next slide, please. So now we're at the outlook about further standardization of AESA, because this guidance represents really the first step towards standardized AESA. And I think it's likely that further steps will involve more specific requirements than what we gave in this guidance document. But it's also important that we allow science to evolve, because it would be a shame to make some extremely specific requirements and then realize a year or two later that this was actually quite wrong to make these requirements, because we have become wiser due to scientific development. A couple of days ago, we actually published a very short column in the Journal of Industrial Ecology where we both highlight the guidance, but also have some reflections about further standardization of AESA. So we welcome you to look into that. And that, I believe, was the last slide.
Great. Thank you so much, Andrea and Anders. Now it's time for questions. And to the audience, please use the Q&A function to ask your questions. Yes, let's see here. We start. Why does the guidance document not provide a recommended list of carrying capacity values?
Perhaps I'll take that, Hannes.
Sure.
Okay, yeah, no, that's a very good question. So there are really two separate answers to that. So on the one hand, the choice of the carrying capacities depends on the goal and scope of the assessment, right? So you can pick, for example, Anand shown two ways. One was related to LCIA impact categories, another one was related to planetary boundaries. So depending how you want to communicate your results, the goal of your study, for example, you may choose one or another. And also because, and this goes back to what Anand was saying in the last slide, that this is a methodology that is maturing very quickly, and we realize that, but we do not want to constrict or limit this the science right behind it, because there is a lot of science being done on estimating carrying capacity or planetary boundaries. So we do not want to limit this, and we want to give enough flexibility for future practitioners as the science evolves.
Okay, great. Thank you so much. We'll continue here. Why does the guidance document not recommend an equation and data set for each allocation principle?
Maybe I will also,
yeah.
Oh yeah, sorry. No, go ahead, Andrea.
Right. Yeah, I'll take it. I'll be quick, and then you can add on that. So, and I think the reason is similar. The answer is similar to the one before. The allocation in AISA is perhaps the most critical aspect or step that, as Anand was mentioning, because this is very value laden and subjective. So when you look at principles, there is not one right or wrong principles. There are many. Okay, so there is really no consensus around these principles yet, and also no consensus how to operationalize them in terms of equations and the underlying data. And because there is not this consensus, again, we did not want to limit or constrict basically the future practitioners into an inflexible framework. Rather, we wanted just them to know what are the potential principles, giving them the flexibility to pick and operationalize the one they think it's most suitable.
Okay, great, thank you. We will continue with the questions from Q&A. How known is this framework in industry? Product LCA, EPDs, and PCFs are currently being demanded by investors and purchasers. Is this method still too new to be demanded, or do you see some demand?
Maybe I can try to answer that question. So it's definitely a new method and not demanded a lot these days. But if you look at things like the Science-Based Targets Initiative, this is many investors demand companies to set science-based targets for climate change. And that is really another way of saying AISA. Of course, it's only for climate and it's only for a company, but it's about setting future reduction targets that reflect the global reduction need in light of the temperature limit of the Paris Agreement. And there's also SBTN, the Science-Based Targets for Nature, that are slowly emerging that and trying to do the same thing for other environmental problems. So in that way, we see already signs that this is something that could be demanded in the future. I have also heard from people I've been in dialogue with and taking courses that some investors are starting to ask questions about projects viability in an absolute sustainability perspective. It's still early days, but it is starting.
Okay, great, thank you. We will continue. It seems that the cost of externalities that include the cost of environmental impacts, for example, cost of carbon, are not included. Can the methodology be changed to account for them to get a more realistic assessment? As many times I feel economics and environmental are mutually exclusive.
Would you want to try that one, Andrea? Otherwise, I can also
try that.
Yeah. So if I understand, I'm not sure I understood the question, but I think the point is that, so I know that there are LCIA methods that try to put everything in the units of money. So saying, well, so and so many tons of CO2 corresponds to this much societal cost. And then you can do it for other environmental impacts, etc. And I think this falls within the sort of mainstream environmental economics, where you try to regulate the environment by getting the prices right. I would say, but maybe people will challenge me on that, but I would say that the concept of planetary boundaries and carrying capacities, and therefore also absolute sustainability, takes more of an ecological economics perspective. So saying that actually it's not something we cannot just pay enough money to fix some environmental problem, that there are certain limits to pollution and resource uses that we ought to stay within as a society.
Okay, thank you. There is international standard for doing the LCA already, available in the form of ISO 14040 series. How AISA is different from the ISO standard?
Okay, no, that's a good question. Perhaps I can take that, Anas.
Sure.
So AISA is so as we showed in the guidance in this framework, AISA builds upon the LCA standards because we really took that as the basis, but it deviates in a number of ways. For example, in the way you choose your carrying capacities, or in the way you interpret your results, as well as for the requirements to allocate carrying capacities to your system. So it builds upon the existing standards for LCA, but it deviates in some crucial aspects that enables basically this framework to be methodologically robust. So I hope that answers the question.
Okay,
I could maybe add that one way that it deviates from the ISO standard, as I know it at least, is that it always requires attributional modeling framework, whereas some existing LCA standards will say, well, in some decision context you should apply consequential modeling, but for internal consistency you really need attributional modeling when you do ISA.
Okay, thank you. We will continue. Any published study or reference for the effectiveness of decision-making based on AISA compared to a conventional environmental assessment, for example, LCA?
I can try. Maybe you can compliment me, Andrea. Well, I've seen some studies. It's a little bit answering the question. I've seen some studies that are looking into the rate of emission reductions of companies that have science-based targets versus companies that have other targets that are less ambitious. And what you typically see from those studies, though it sometimes deviates, but the typical pattern is that the companies that have these ambitious reduction targets, they typically also reduce emissions at a faster rate than companies that maybe just have some sort of arbitrary target of we want to reduce 5% in 5 years or something like that. That used to be the way that companies set targets, where it's disconnected from global challenges. So I would anticipate something similar to happen when a company transitions or an organization transitions from doing normal LCA to doing AISA, because it really puts a spotlight on the magnitude of the challenge, and that any small percentage improvement is simply often not good enough. But I have still to see a study actually looking at the effectiveness, as you say.
Okay, thank you. Which software are you using for absolute environmental impact assessment?
Perhaps you can take that, Anas, as well.
That's gonna be fast because I'm not using any. Well, so far, of course, since AISA builds on LCA or corporate carbon accounting or environmental input output analysis, you are using those softwares that relate to those existing environmental accounting tools as a starting point. And then it would be really wonderful if there was some sort of software that also has integrated the carrying capacity and the allocation step. That doesn't exist yet, unfortunately. But we, at least at DTU here, we are in communication with some software developers to hopefully implement that, to sort of remove that barrier for implementation.
Okay, the last question. What is the link between SBTI and absolute environmental sustainability assessment?
Should I take that one as well.
Yeah,
Sorry
I think
for...
you already
yeah,
linked
because
that.
my previous answer to some extent gave it. So SBTI is only companies that are the focus and only for climate change. So in that sense, you can consider it a limited version of what we call AESA, because AESA can be applied at different scales, companies, countries, but also households and products and so on. And then a key feature of AESA is to try to be comprehensive in your coverage of environmental problem areas, because otherwise you could end up with climate solutions that are, yes, perhaps bringing us to net zero in a reasonable time horizon, but then could increase pressures on other environmental problems that then make it environmentally sustainable still. So that those are the differences.
Yep. Just to add on that in the guidance, actually, one of the case studies we provide is actually a study on SBTI, the study
Yes.
on the company, a cement company. That's an SBTI study. So that shows basically the link between SBTI and AESA.
Okay. Thank you so much, Andrea Paulillo, lecturer in Sustainable Chemical Engineering at University College London, and Anders Bjørn, Associate Professor in Sustainability Assessment at the Technical University of Denmark.
You're very
Thank
welcome.
you very much, Anna,
It was a
for
pleasure.
inviting us. Indeed.
And if you're interested to know more about this field of research, these publications are a good start. And all that is listed on this slide and the second slide can also be found on the Swedish Life Cycle Center website in the calendar event for this talk. The Life Cycle Talks are published by the Innovation Cluster for the Life Cycle Perspective and Swedish Life Cycle Center. And thank you so much for listening. The next Life Cycle Talk will be in December, and it will be about EU environmental policies. And please follow Swedish Life Cycle Center on LinkedIn, and feel free to subscribe to our newsletter to keep up to date with Life Cycle Talks and our other events and information. So thank you. And here's the contact information to Andrea and Anders.